Hi, this video explores how sacred geometry is embedded within Durham Cathedral. I start by quoting the following passage, Wisdom 11:21 from the Bible. And so, God, who created all things in measure, number and weight. Measure pertains to geometry, number to arithmetic, and weight to music. Geometry therefore has a divine origin which the medieval builders or masons applied as co-creators with God. My initial research takes a look at the following: a mathematical look at a medieval cathedral, written by Hugh McCaig. Hugh McCaig did a number of years of research looking at how sacred geometry or number was applied to the construction of Durham Cathedral. His research includes a Masters of Arts and PhD degrees. If we look at the top, it says, a master mason could adeptly and repeatedly apply a few simple geometric operations and tools, such as the mason's large compass, to produce a myriad of sophisticated designs. And the one we'll be looking at is here. The side of the square to its diagonal, however, has the strongest pedigree in terms of historical documentation in building manuals, diagrams and illustrations. And if we go to figure 6, this is what we'll be looking at. We'll be looking at the square and the diagonal and how this relationship was used by the masons in the construction of Durham Cathedral. The ratio of the side of the square and its diagonal has a long history of use in building practice. This takes us all the way back to Vitruvius. Vitruvius was a Roman author, architect, civil engineer and military engineer during the 1st century BC, known for his multi-volume work titled De Architectura. His discussion of perfect proportion in architecture and the human body led to the famous Renaissance drawing by Leonardo da Vinci of Vitruvian Man. The ratio is referenced within De Architecture within a number of places. If we go to Book 1, Chapter 2 and Part 2, it states, a ground plan is made by the proper successive use of compasses and rule, through which we get outlines for the plane surfaces of buildings. Also, if we go to Book 6, let's find Book 6, Book 5, Book 5, Book 6, and we go to Chapter 3, and we find Part 3, Part 3. In width and length, atriums are designed according to 3 classes, and the third by using the width to describe a square figure with equal sides, drawing a diagonal line in this square and giving the atrium the length of this diagonal line. If we take a square with sides equal to 1, Pythagoras shows us that the diagonal will have a value of root 2, and this gives us an area for the square of 1. If we then subtend the diagonal as an arc to the line, that gives us a value there of root 2 on the line. If we then form a square from the value of root 2, we have a new square with sides of root 2, which gives us a new area for the square of 2. So what we're in effect doing is doubling the area from 1 to 2 using Pythagoras and using geometry. This is a view from inside Durham Cathedral, looking down the nave towards the west window. This next view is also looking down the nave, looking east towards the rose window. Referring back to figure 6, I can now show how the relationship of the square and its diagonal relate directly to the dimensions of Durham Cathedral. We'll be looking at particularly the original plan of Durham Cathedral showing the apse, and this was before the Galilee Chapel and the Chapel of the Nine Altars were added. So we're looking at the first set of dimensions, because two are shown here, but we're only going to look at the first one. So the first dimension is HB. Now HB is the interior length of Durham Cathedral up to the chord of the central apse, and it is from here up to the chord of the apse there. The next dimension is HC. Now HC is the interior length of the tower, nave and transept, and it's this dimension from here up to there, and that's HC. And what it tells us, that this ratio HB to HC is as the side to the half diagonal of a square, and the relationship is root 2 to 1. So HB will be root 2 and HC will have a value of 1. In particular, the specific dimensions again are 113.3 metres and 80.17 metres. For the full length measurement, Hugh McCaig used mainly Billings' original plans. Professor Eric Fernie has also completed research showing similar results related to other Anglo-Norman cathedrals. Further investigation shows how the diagonal and square are used in the construction of Durham Cathedral.
The ratio of 1 to the square root of 2, for example, crops up in lots of cathedrals. It's a formula that suggests some pretty sophisticated mathematics. In fact, it's very easy to generate using some basic geometry. Simply draw a square and then draw a diagonal across it, and the relationship between the diagonal and the side of the square will be in the proportion of 1 to the square root of 2. So if you take the ground plan or footprint of a cathedral like Norwich, for example, the cloister is a square. Draw a diagonal across it, and you get the length of the nave. Create a square from that length, and a diagonal across that square gives you the length of the entire church, right up to the high altar.
The first set of dimensions are taken from a digitised version of the Architectural Illustrations and Description of the Cathedral Church at Durham. This was published by the cathedral architect R.W. Billings in 1843. The first measurement was taken of the cloister length along the wall of the nave. The second measurement is the length from the west wall to the transept crossing. Plate 5 is a plan view of Durham Cathedral with all the dimensions as measured by Billings. The side of the square is represented by the length of the north side of the cloisters, here shown in red. The diagonal of the square is represented by the length of the nave from the western wall up to the transept crossing. And if we zoom in, we can see that the length of the cloisters was measured by Billings and stated on his drawing as 145 feet and 6 inches. Billings measured the length of the nave and recorded this length on his drawing as 205 feet and 4 inches. Transferring these measurements to the side and diagonal of a square results in an error of 0.21%. This error is well within acceptable measurement for establishing the ratio which would have been used by the master mason for building Durham Cathedral. Hugh McCaig repeated the measurements as part of his thesis in the 1990s. His results were very close to Billings' original measurements, giving an acceptable error of 0.26%. He also produced an article called A Mathematical Look at a Medieval Cathedral. His measurements are repeated in metric in Figure 7, resulting in an acceptable error of 0.25%. Further research took me to Eric Fernie's bibliography, and if we scroll down, we come to his article in 1976 titled The Ground Plan of Norwich Cathedral and the Square Root of 2. This has since been superseded by his book in 1993 titled An Architectural History of Norwich Cathedral. Norwich Cathedral is of similar Norman construction to Durham, and building was started at approximately the same time in 1096. In his article, Eric Fernie subdivided Norwich Cathedral into units of 5.5 metres. The eastern arm, shown here, the transept, shown there, and the cloister, here, are all 10 units in size, while the nave is 14. Since the nave and the aisle are 4 units in width, the cloister plus the width of the church equals the length of the nave, shown there, which is 14 units. So 10 to 14 is a proportion of 1 to root 2. Further examples of the root 2 proportion are discussed in the rest of his article. It is important to note that 14 to 10 is a ratio of whole numbers that was known to Roman and medieval builders as an approximation to the length of a square's diagonal to its side's length. The final part of my research investigates the proportions of Escombe Saxon Church. Escombe is a village on the River Wear, about 1.5 miles or 2.4 kilometres west of Bishop Auckland, County Durham in England. The church is one of the oldest and most complete Saxon churches in England. Architectural evidence points to it being built sometime between 670 and 690 AD. This would make it one of the first Northumbrian Christian churches to be built. Eric Fernie has researched the proportions of Escombe Church in his book titled The Architecture of the Anglo-Saxons, published in 1983. Specific dimensions of the church are recorded in his book and used in the following extract from page 56. As well as being executed with impressive consistency, these dimensions bear neat geometrical relationships to one another, since the diagonal of the square in the chancel, shown here, equals the width of the nave, and that in turn, multiplied by 3, equals the length of the nave. To summarise, Durham Cathedral does not stand alone among Norman buildings in using squares and their diagonals and root 2. The master mason has always been able to use simple tools and sacred geometry in the construction of magnificent Anglo-Norman and medieval cathedrals and churches.